Good afternoon, sir. I am JL Galinero, and once again, I am tasked to create a um, function which is in terms of Boole's rule. So, as you can see on the screen, sir, I have here the header, which is the Boole's rule, and on the left side, we have the initializations of the equation and also the um, sixth derivative of the equation and also the values which we have here. We have A, we have B, we have segment, and also I included the place value and what kind of variable that we need to use, and also the button solve. And on the lower left, we have here the value of H, we have here the value of I, and also the error here, and also um, the final value for our I. And on the right side, we have the iterations, which is the first column is the segment, or I let it as n. Then we also have the second column, we have x, and the third column is the function of x, and the last column is the iteration which we apply Boole's rule or the equation from on how we get I. Okay, for example, sir, I already included in the equation here as 0.2 plus 25x, and this is the equation where we can find on our exercise number 2. And also, when we integrate this one, um, I mean, when we differentiate the equation to its sixth derivative, it will come up with 0. And also, we initialize the A as 0, we initialize B as 0.8, and segment as 4, and variable of x and place value 5. And after this example, I will also give another example which in terms of trigonometric functions. Then when we click the solve here, we have the values for h, we have the values for I, we have the values for et, and also the IA. And the iterations also will be shown. And as per the example, we have the h as 0.2, I as a 1.64 64053, and we have the error as 0 because we have the sixth derivative of our function as 0. And also, our IA is equivalent to I plus ET, which is 1.64053 plus 0. And also, we have the iterations, which end segment is also refers to as what we input to our segment, which is 4, and that is the iteration. We have the 5 iterations from 0 to 4. And when we solve for x, again, we have the um, formula for solving the x is 0, 0.2, 0.4, 0.6, 0.8. And when we apply these values from our x to the corresponding function from here, we have 0.2, 1.28, and so on. And also when we apply the Boole's rule here, we can find 1.4, we have 41.216, 29.472, and so on. Okay, let's just have another example, which is sine x, and Also, its sixth derivative, x is negative sign x. Of course, we have a as 0, we have b as 5, we have segment as 10. This is a more than 4 segments. And when we click solve, it will give us another iterations and another value for our h, I, e, t, and I, a. We have h is equal to 0 0.5, I is equal to 0 0.69165, and the error term is 0 0.00009. And we have IA is equal to 0 0.69174. And the iterations, we have from 0 to the 10th number. So we have 11 iteration. And for solving the x, we have here, this is x plus the h. And for the fx, we just need to substitute the value of x from our function. So when sign 0, that is equivalent to 0. And also when we multiply the function of x from our Boole's rule equation, that is also 0. 7 times 0, and we have here, so on. And to clarify how this works, I need to show my code, and here's my code. Okay, from the upper part, I imported a library which solve for our math formulas, or the string from our inputted equation will be read as an equation. Okay, and I also declare functions to initially get the equation, the differential equation, which is the sixth derivative, the variable, and the value of a, the value of b, the segment h, which we have the formula, that is b minus a over the segment, or n. We have also x, the value of x, which is I store the value of x from our array x, and also the function, value of the function we have here, and the value for our Boole's rule. When we apply Boole's rule, this is the iteration part, which is I encoded, and here, and the total of the iteration from the BR column, or from the Boole's rule, uh, summation of the Boole's rule function. Okay, then we have the button solve we have here. So to get the x, just call the function of x. To get the function of function, just need to call the get f function and the br function. And also I let the I as I value, then ia value, and get h value. This will be shown on the lower portion of the code, and the error term, and also the iteration part of my code, and to show the iteration part of my code, just the I for I, and the segment. 0 to the segment. Then we have x, the function, and the Boole's rule function. I also have here the function which I trim the function when we have the variable of x, it will be changed to uh, asterisk or times x, and also I need to replace the other symbols if we have this space in the equation, and if the asterisk is besides this special symbols, this one also, then um, this one. So this is the trim function or the trim equation, and this is the error term on how to get the error term. This is the equation here, which is I also created a function for that one. Then I also get the I value and the IA value. Then the get function for our function, and again I've used the header function or the library, which is calls the function and its argument and the expression, and also the calculated part of the expression. And for this one, this is for the second function. It is also the same concept for our get function, but this is in terms of the integration part. So this is my integration part, and this is for the function part for our error. Then this is for the label, which is shown for our age and etc. And for this one, this is the function for getting the between part of a string and before a string and after the string.